Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that's crucial for anyone serious about a career in tech: professional software engineering. We're not just talking about writing code that works. We're talking about building large, robust, and maintainable software that can evolve over years and be worked on by huge teams. This is what separates a hobbyist from a professional engineer. So, what does it really take to build software at scale? The first and most fundamental concept is moving from a solo mindset to a team mindset. When you're working on a personal project, you can do whatever you want. But in a professional setting, your code needs to be understood, modified, and extended by others, maybe even years after you've left the company. This is where standards and conventions become your best friends. Think about coding standards. These are a set of rules for a specific programming language that recommend programming style, practices, and methods. They cover everything from how you name your variables and functions to how you structure your files. It might seem trivial, but when dozens of engineers are contributing to the same codebase, consistency is king. It dramatically reduces the cognitive load required to understand someone else's work, making bug fixing and feature development much faster. Most companies have their own style guides, and tools called linters can automatically enforce these rules for you. Next up, let's talk about version control, and specifically Git. If you're not using Git, you need to start right now. It's the industry standard for tracking changes in your code. But just using Git isn't enough. You need to use it well. This means writing clear, descriptive commit messages. A commit message like fixed bug is useless. A message like fix, corrected user authentication race condition, tells a much clearer story. We also use branching strategies like Git flow. This is a system where you have a main branch for stable production code, a develop branch for upcoming features, and separate feature branches for individual tasks. This keeps your codebase organized and prevents developers from stepping on each other's toes. Now, let's zoom out a bit and look at the bigger picture. Software development methodologies. You've probably heard of terms like Agile and Scrum. These aren't just buzzwords. They're frameworks for managing complex projects. The old way of doing things was the waterfall model, where you'd spend months on planning, then months on design, then months on coding, and finally, testing. The problem is, by the time you're done, the world has changed, and what you built might no longer be what the user needs. Agile, on the other hand, is all about iteration. You work in short cycles, usually 2 to 4 weeks long, called sprints. In each sprint, the team commits to delivering a small, usable piece of the final product. This allows you to get constant feedback from stakeholders and adapt to changes quickly. Scrum is a popular framework for implementing Agile. It involves specific roles like the product owner, who represents the customer, the Scrum Master, who facilitates the process, and the development team. There are also key meetings, like the daily stand-up, sprint planning, and the retrospective, all designed to keep the team aligned and continuously improving. Integration tests check how different parts of your system work together, and end-to-end tests simulate a real user's journey through your application to make sure the entire flow works as expected. Writing tests takes time, but it saves you so much more time in the long run. A good test suite acts as a safety net. If the build or tests fail, the team is notified immediately so they can fix the problem. Continuous deployment takes this one step further. If the build and tests all pass, the new code is automatically deployed to production. This might sound scary, but with a robust testing strategy, it allows companies to deliver value to users incredibly fast, sometimes multiple times a day. So we have our process, our version control, and our testing. What about the code itself? This is where software architecture comes in. For a small project, you can throw all your code into a few files. For a large application, that would be an unmanageable mess. You need a deliberate structure. Concepts like solid principles are your guide here. For example, the single responsibility principle says that a class or module should only have one reason to change. This makes your code more modular and easier to maintain. We also use design patterns, which are reusable solutions to commonly occurring problems. Think of them as blueprints for your code. Instead of reinventing the wheel every time, you can use a proven pattern to solve your problem elegantly. The reviewer checks for bugs, adherence to coding standards, and potential improvements in logic or performance. So, to recap, building large software projects professionally isn't just about being a great coder. Working within an agile framework like Scrum, writing comprehensive automated tests, implementing a CI/CD pipeline, designing a clean and scalable architecture using principles like SOLID, documenting your work, and participating in collaborative code reviews. Each of these pieces is a deep topic on its own. But understanding how they all fit together is what will elevate you to a true software engineering professional. It's a journey of continuous learning, but it's what allows us to build the amazing, complex software that powers our world. Let me know in the comments which of these topics you'd like me to dive deeper into next. See you in the next one.